Hi guys, so we'll be solving an O-level past paper question from the year 2017. The session is October-November. This is question number 9. We'll calculate the volume of a cylinder, the area of a cross section, the time taken for a car to travel through a tunnel, and bearings. So let's start. Question 9a reads, the ventilation shaft for a tunnel is in the shape of a cylinder. The cylinder has radius 0.4 meters and length 15 meters. Calculate the volume of the cylinder. To calculate the volume, we use this formula, pi r square h. So you do volume is equal to pi, which has a standard value 3.142, times the radius, which is 0.4 squared, times the height. Let's plug this into the calculator. So you do 3.142 times 0.4 squared times 15. This gives us 7.54 meters cube. So you write 7.54 meters cube and the final answer over here, 7.54. Okay. The next part says the diagram shows the cross section of the tunnel. Here is the cross section. The cross section of the tunnel is a major segment of a circle with center O. The radius of the circle is 4.5 meters and AOB is 110 degrees. Calculate the area of the cross section of the tunnel. This cross section is divided into two parts. First of all, this circle over here, part of a circle, and then this triangle over here. So we need to add the areas of these two shapes together. So let's find the area of AOB, the triangle, first. This is also 4.5 meters. Okay, so the area of triangle AOB can be found by using this formula, half AB sine C. Let's plug in these values. So you do half times 4.5 times 4.5 times sine 110. Let's see what we get. We do 0.5 times 4.5 times 4.5 times sine 110. So we get 9.51 meters square, which is the area of the triangle. Now let's find the area of this part over here, that is not the triangle but the circle. So you write segment, or not even a segment. Let's say it's just AOB. But how do we find the area of AOB? So we look at this angle first. This is 110. If we find this angle and use the area of a circle's formula, we can find the area of this part. So first of all, the formula that you use is, you subtract 110 from 360 and divide that by 360 and multiply the entire thing by pi r squared. So when you do this, 360 minus 110 gives you 250. You divide 250 by 360 and multiply it by 3.142 times the radius was 4.5 squared. Okay, let's plug this into the calculator. We do 250 over 360 times 3.142 times 4.5 squared, and eventually we get 44.2 centimeters squared. Now we have the area of the segment AOB and the triangle AOB. So we add the two areas. We add 9.51 and 44.2 together, and let's see what we get. 9.51 added to this gives us 53.7. So we write 53.7 meters square, which is the area of the cross section, and we write it over here, 53.7. Okay, let's move on. The next part of the question says, the length of the tunnel is 1750 meters. The car drives through the tunnel at an average speed of 45 kilometers per hour. Work out the time the car takes to travel through the tunnel. Give your answers in minutes and seconds. So first of all, we need the formula for time. Time can be calculated by dividing distance by speed. The distance is of course 1750 meters and the speed is 45 kilometers per hour. So if you spot the difference, the distance is in meters and the speed is in kilometers per hour, and you need the time in minutes and seconds. So what you do is, first of all, you multiply 45 by 1000. Why do you multiply it by 1000? Because 45 kilometers converted to meters would be 45,000, and you divide this by 60. When you do this, you get 1750 times 60 over 45,000. Now that seems like a big number, but let's put this into the calculator. So we do 1750 times 60 divided by 45,000, and we get 2.333 and over dash. Now this is the number of minutes, but we have to convert this into minutes and seconds. So of course the first digit, that is 2, becomes the minutes, so it's 2 minutes. But when you multiply 0.33333 by 60, you would get the number of seconds. So you do 0.33333 by 60 and you get 20 seconds. That's your answer. You write 2 minutes and 20 seconds. Let's move on. The next part of the question says the diagram shows the position of the tunnel entrance T and two road junctions P and Q on horizontal ground. Then they've given you this diagram. Q is due north of P and T is on a bearing of 062 degrees from P. PT is 450 meters and QT is 720 meters. Calculate the bearing of T from Q. So we need this angle right here. I hope this is visible. We need this angle right here. If we have this angle and subtract it from 180, we would get this angle that we're trying to look for. But how do we find this angle? Let's call this x and let's call this y. So first we need to find the value of x. We use the sine rule to find the value of x. So you do sine x over 450 is equal to sine 62 over 720. Okay, let's plug this into the calculator because we're trying to find the value of x. So sine x would be equal to 450 times sine 62 divided by 720. So sine x would come out to be, let's see what we get, 450 times sine 62 divided by 720. We get 0.55184. Okay, I'm using the entire value. So x would come out to be, let's do sine inverse of this value. X would come out to be, 33.5 degrees. Okay, so we have x. If we subtract this from 180, we would get the value of y. So we do 180 minus 33.5 to get the value of y or the bearing of T from Q. When we do this, 180 minus answer gives us 146.5 degrees. So the value is 146.5 degrees. I hope this made sense. We write the value over here, 146.5. I hope this question made sense. The complete working of the entire question is present in the description below for you to download. If you like this video, hit the subscribe button and thank you so much for watching.